Hi, so today we're going to talk about the prediction on real estate house pricing. So our group members consist of Ahvinraaj, Hanisah Zulaikha, myself, Nur Erdina, and Nur Aqeela. So for the introduction, what is real estate and what is the purpose of this project? So real estate is the land of any permanent improvement attached to the land, whether natural or man-made, including water, trees, minerals, buildings, homes, fences, and bridges. Real estate is a real property. It differs from personal property, which is property that is not permanently attached to the land, such as vehicles, boats, jewelry, furniture, and equipment. So the purpose of this project is to predict the real estate housing. Because of that, our team has decided to work on the analyst's job of analyzing and predicting real estate pricing based on the dataset that we found on Kaggle website. Next is the problem description. So problem descriptions consist of two sections, which is business goal and technical goal. So under the business goal is the project is about the prediction of real estate prices based on the sales of the real estate dataset that contain a whole lot of data being made as a research and observation. The objective of our project is to study the prediction of certain real estate in the industry. The benefits of investing in real estate includes passive income, stable cash flow, tax advantages, and leverage. Besides that, people usually invest in real estate as well to symbolize their wealth. The project is also about the studies of how real estate market will impact each price. So these objectives are to highlight the purpose and view of how real estate is going in the market nowadays. Next is technical goals. Technical goals, there are two analyses, which is descriptive and predictive analysis. So some of our descriptive analysis problem are which house does not have the longest age and which house number is the nearest to the MRT station, while our predictive analysis are predicting house price based on the house age, distance from MRT, and number of convenience store. Next is data explanation. As you guys can see from the slides, there are some attributes in this data, which is transaction data, house age, distance to MRT, number of convenience store, latitude, longitude, and house price. So as you can see, besides the attributes, there are the description for each attributes. Let's move on to the data preparation, which is load data, check for missing values, drop features, and graphical analysis. So for the data description, we first and foremost identify the type of data for each column and display to form of a table. So basically, we search for the dependent and independent variables. Next, we check for the missing values, and then we drop some features after we checked the missing values, and lastly the graphical analysis. So basically, then we move on to the preparation of the data, which is the load data, providing details of our data sets while visualizing. We're using the histogram, scatter plot, and the line plot. To be honest, this part took us a lot of time, and we managed to cleanse the data.
Thank you, Erdina, for the wonderful and clear explanation. Hi, sir, and hi, everyone. I'm Ahvinraaj, and I'll be continuing regarding data visualization. Let's begin with scatter plot. For this research about predicting real estate price, we have generated three scatter plots. First, house price versus house age. This scatter plot shows the lower the age of the house, the higher the number price of the house. The second scatter plot is the house price to distance of MRT. This shows the shorter the distance of the house to MRT, the higher the price of the house. The third scatter plot shows house price versus number of convenience stores. This plot shows the higher the number of convenience stores, the higher the price of house. Next, we are continuing with box plots. These are the box plots of our research. Is to measure how well distributed is the data in a data set. It divides the data into three quartiles. This graph represents the minimum, maximum, median, first quartile, and third quartile in the data set. Now, we have the histogram and correlation visualization. As we can observe here, the highest strong correlation will be the house price and the number of convenience store. There is also some relatively strong correlation, which is house age and the number of convenience stores and the house age and distance to MRT. We can imply that the house age, the distance from the house to MRT, and the number of convenience stores affects the price of the house. Now we are looking at the solution of our research. We have the descriptive analysis and predictive analysis of our research. Next, the summary statistics tells us the number of things. One of them is a model p-value and the p-value of individual predictor variables. The p-variable are very important as we consider a linear model to be statistically significant only when both of the values are less than the predetermined statistically significant level, which is ideally 0.05. This is usually interpreted by the significant stars at the end of the row. Now we come to the conclusion of our presentation. The conclusion of our presentation is the predicted price increases. Second, it is important to keep an eye on the house price and always promote so that it can attract a lot of buyers. Third, it is highly recommended to keep a high and good data maintenance of further studies, which will allow to capture correlation with more data in a longer series. Fourth, linear regression model is the best fit for our problem as the AIC value of 3022.972, BIC value of 3043.101, MAPE value of 20.02%, and mean max accuracy of 83.94%. The correlation accuracy is total of 73.6%. Our initial hypothesis is proven correct in this project where the housing price will increase in the prediction. Thank you very much everyone, and thank you for Sir for giving us this opportunity to conduct this project, and thank you for my wonderful team members which makes this project possible. Thank you.